This is kind of a big one. Okay, this again we're going to do the inverse function. So again, when we do the inverse function, we're going to start by making that a y. Y is equal to negative 4x plus 4 over 7 plus 3x. However, when we do the inverse, we switch the x's and the y's. So anything that's a y, we're going to make an x. Anything that's an x, we're going to make a y. So now I'm going to have x equals negative 4y plus 9 over 7 plus 3y. So anything that's a y, we change to x, and anything that's an x, we change to y. Now we have to solve this crazy looking equation. Again, we start out this one has a fraction. Our first step should be getting rid of that fraction. So we're going to multiply by the 7 plus 3y. So that we can cancel the fraction out of there. Here then we would have to use our distributive property. So we would have 7x plus 3xy. And if you wrote yx instead of xy, it's the same thing, right? So 7x times 3xy equals our negative 4y plus 9. Okay, we want to solve this for y. That means I want anything with a y on the left side, anything that doesn't have a y on the right side. So, this doesn't have a y. I got to move that over there. This has a y. I've got to move that over here. Whoops, I better put an x behind my 7. So if it doesn't have a y, move it to the left. If it does have a y, move it to the right. So we have 3xy plus 4y equals 9 minus 7x. So everything with y's are on the left, everything without y's are on the right. Now what we're going to do is we're going to factor the y out of these two terms. So we're just going to take the y out, put it in front. If we take the y out, we're going to get 3x plus 4. Now the only last thing we need to do to get the y by itself is divide by that 3x plus 4. That's going to cancel that, and so that's going to end up being our answer. So they'll write it this way. In functional notation, they write it with that -1. This is going to be our answer. 9 minus 7x over 3x plus 4. Now, if that wasn't enough fun, they still have a second part to this question, besides finding the inverse. The second part to this question says, give the domain and the range. The domain of a fraction. The bottom of my fraction can't equal 0. So the domain says that 3x plus 4 cannot equal 0. We have to solve that. So we're going to minus our 4. 3x can't equal -4, and divide by 3. X can't equal -4/3. Now in interval notation, as if they haven't done enough crazy things to us, it looks really weird. It's every point except for that one, and so here's what it's going to look like when you put your answer in. You're going to go from -infinity to this point, parentheses on both ends because you're not going to touch either end, and then you're going to do the union sign, and then you're going to start at that point and go to +infinity. And that's how they're going to want you to put the answer in. Once you get that number, you're just going to put it here and here in this crazy looking expression.
Wow.
Now we're not even done yet.
Oh, next.
Because we did the domain, but we haven't done the range. So on the range, we're going to do the same thing we just did, only we're going to use this one. So for our domain, we use that. For our range, we're going to use this one. 7 plus 3x cannot equal 0. So again, we got to solve it for x. We're going to minus our 7 first. 3x cannot equal negative 7 then. And then divide by 3. X can't equal negative 7/3. And again, they want the answer in interval notation, so it's going to look just like this, but this time I'm going to put the negative 7/3 in. So I'm going to say negative infinity to negative 7/3, and then negative 7/3 to positive infinity.
Oh, I know I can get this one.
All right. Well, that's just the first time you saw it. We're going to do 2 more.
Okay.
So, number 11 wants us to do the inverse. We're going to find g to the negative 1. We know that this is supposed to be y. To save myself some space, I'm not going to rewrite it. I'm just going to go ahead and switch. So, I'm going to do x equals negative 2y over negative 8 plus y. Switch my y to my x and my 2 x's to y's. I need to solve that. What should I do first if I'm going to solve that?
You're going to go y?
I want to solve it for y, but the first thing I need to do, get rid of the fraction.
You're going to multiply by 2.
No,
Oh.
I want to get rid of the fraction, so I want to multiply by the bottom, right?
Oh, okay.
The negative 8 plus y. Because then I can cancel that fraction out of there. So, using my distributive property here, I'm going to get what?
You're going to get 16.
Where are you getting 16 from?
Oh, you're going to get
I'm multiplying
negative
this. So negative
X
8x
plus xy.
xy equals
Negative 2y.
negative 2y. Now our next step. We want anything with the y on the left, anything that doesn't have a y on the right. So what do we need to move?
You need to move your 8x
Okay, and when I move that over, it's going to be
positive.
positive.
And then your 2y is going to become positive.
And so we have xy plus 2y equals, I don't really need the plus sign in front of there, I'll just write it as 8x. Now our next step is factoring the y out. If I put the y out in front, what goes in my parentheses?
X. Oh no, y. Oh, x. X.
Because I took the y's out,
We took the y's out.
so I have x
Plus 2.
plus 2, exactly. My last step is getting the y by itself by dividing
Yep.
by my x plus 2. So, g of negative 1 is going to be 8x over x plus 2. Well, this time solving our domain and range will be a little bit easier because we don't have coefficients in front of our x's. For my domain, on my domain, I am using the denominator of my answer. So for my domain, I'm going to say x plus 2 cannot equal 0. So if I'm going to solve that, I would do what? If I have x plus 2 can't equal 0, how do I solve that for x?
Move your 2 over.
Move my 2. I'm going to minus my 2.
Yeah, minus your 2.
So x cannot equal negative 2. I don't have a number in front of my x, so I don't have to do the dividing on this one. I'm going to put that in my interval notation. So I'm going to say negative infinity to negative 2, and then negative 2 to positive infinity. After I do my domain, I'm going to do my range. When I do my range, I'm using the denominator of my original function. So I'm going to say negative 8 plus x cannot equal 0. And then I have to solve that one for x. So if I'm going to solve that one for x, I'm going to...
Are you moving to 8?
I'm going to move my 8, so I'm going to make it a plus 8. X can't equal 8. I then have to put it in interval notation. So what's my interval notation going to be?
Is that going to be like your answer?
It's going to be negative infinity to 8.
8.
And then
8.
8 to
Negative.
positive
Oh,
infinity.
positive. I am not going to get this.
You can always give it a guess if it happens to pop up on your final.
Are you going to put the answers? I mean,
I don't know what comes up. It all depends on how much you got done in your pie chart. So those might not even pop up because you might not have it done on your pie chart. Okay, number 12. Same thing. We're going to find our inverse function first. We know that in regular notation that's a y. To do our inverse, we're going to switch it around. So what should we have?
so you're going to have y equals,
Instead of y equals, we're going to change it to
oh, x.
x equals
Negative 4 x plus 9. 4y.
negative 4y plus
4y
9
plus
over
9 over 9y minus x. I mean minus 8.
minus 8. Okay, we switched our x's and our y's. Now we have to solve it and put it back so y is by itself. So first thing we need to do is
We need to multiply it by 9. 9y minus 8. That cancels out.
so we get
9y minus 8x.
now what do we do with this x?
Oh,
We got to use our
Oh, yeah.
distributive property, right?
yep, forgot that step. So we got 9xy, xy, and minus 8x.
Mm-hmm. Equals
8x equals 1 negative 4y plus 9.
plus 9. Okay. Now, what is our next step?
The next step is to get rid of the y.
We're never getting rid of the y. The y is always in our answer somewhere,
Okay,
but
so
we want to
it's gonna be-
rearrange it.
Oh yeah, it's gonna be, you're gonna take your y over to the left. It's gonna be positive y.
Positive
Oh,
4y,
Oh yeah,
right?
yeah, and then your 8's gonna be, positive 8.
Okay, so we have 9xy plus 4y equals 9 plus 8x. Then what did we do?
9xy, 4y, and then we, well, this one's different.
It's not a lot different. Once we got our y's together, what did we do with our y?
We, distributive,
Factored it out.
yeah, factored it out.
The opposite of the distributive property, we factored it out. So if we factor out our y's, we are going to get
9x plus 4.
9x plus 4 equals our 9 plus 8x. And then our last step,
Our last step, we divided.
we divided by the 9x plus 4. So our inverse function is equal to 9 plus 8x over 9x plus 4. That's the first answer you're going to put in. Then we have to do the domain.
I got to do the
What did we do to do the domain?
We did x, no, that's the last step I got. But I got, the domain x, not x plus 8.
And where'd the x plus 8 come from?
The top. 9 plus 8, cannot equal 0. 9 plus 8x.
Nope. Look at your problem again. Where did that one come from? When we did the domain, we set something not equal to 0. What was it?
I had to write a note piece of paper.
So, where did this come from? Go back to number 11. Where did this come from?
I can't even see it. X minus 2 equals 0.
It says x plus 2, it should say, right? X plus 2
Plus 2.
equals 0. Where'd you get the x plus 2?
X plus 2. Oh, right here.
Ah, it's the bottom
The
of your
bottom.
fraction. Because the bottom of a fraction can't ever equal 0. So it's always coming from the bottom.
Bottom.
The bottom. So the bottom of this answer is 9x plus 4 can't equal 0. Because division by 0 is undefined, the bottom can't equal 0. Now we got to solve that. So we're going to minus our 4 first, right?
Yeah, minus the 4.
So 9x can't equal negative 4. And then we're going to divide by our 9. So now we need our interval notation.
So that's going to be negative
So negative infinity
infinity
to to
negative 4,
negative 4/9.
4/9,
And
and
then,
the U,
mm-hmm,
and then negative 4/9,
yep,
infinity.
all right.
Is that gonna be negative? No, it's
It is.
positive.
It's positive infinity on the
Yeah,
end.
Yeah, positive infinity, okay. Then the range.
Then the range. Now, how did we do the range?
The top number,
We use not the top number,
line. Negative 8. Wasn't that what I did there?
where'd you get the negative 8 plus x from? That doesn't look like negative 8 plus x.
What does it look like?
No, I mean this.
Oh,
This does look like negative 8 plus x, only you're looking at the wrong problem. We got like a 11.
oh, okay.
So where did the negative 8 plus x come from?
Negative 8 plus x. Oh, right there.
It
No.
actually came from way up here from where we originally started.
Oh, there.
Way up there on the original problem, the range of our answer is the domain of our original problem. So we use 9x minus 8 can't equal 0. And again, it's always the bottom of the fraction, because the bottom can't equal 0.
So then we put 9x cannot equal 8.
Right?
And then we divide.
Yep. So x can't equal 8/9. And then we've got to use our crazy notation, right?
You have the positive infinity.
Yep. Or you start with negative infinity. It always starts because we're going from left to right.
Okay, you always start with the negative.
Yep.
And negative 8/9.
So the only thing that changes is the number in there, right? It always starts at negative infinity, goes to our number, then goes from our number to positive infinity. All right, those are long ones. The next one should be a little better.